We have looked at rectangles, we've looked at parallelograms, we've looked at triangles and trapezoids. We're on to circles. This is one of the few shapes that are not polygons that we take a look at. So a circle has no sides, it has no edges, it has no corners, there's no vertices. It's really just a collection of points. It's a whole bunch of points all going around, and they're all the exact same distance. Whole bunch of little points in there. They're all the exact same distance from one point in particular. And so this point right here in the middle, which we call the origin, because that's where all these points come out from, or the center, all these points are the exact same distance from that point. And we call that distance the radius. Go ahead and please fill that in. The radius is the distance all the points are on that circle from that center point. And so the center point is right in the middle, and you can put that center point anywhere. And then as long as all the points that go around that center are the exact same distance the whole way around the circle, you have a circle. And so that's the radius. The radius is the distance from the center to any point on the outside of the circle. So there's not just one radius. There's one right here, which is in red, but there's also a radius right here. That's a radius from the center to any point on the circle. There's another radius, there's a radius, there's a radius, there's a radius, there's a radius. There's an infinite number of radii, or radiuses, radii. And so we've got all these different radii, all these different radiuses, all going around the circle. And in fact, along this blue line from here to there, that's a radius as well. And from the center all the way over here, that's a radius as well. And so we've got lots of different lines that we can call the radius because it's from the center out. But if we take two of those radii, and they are back to back, and so we're looking at this blue line here. We've got a radius here, we've got a radius here, and if we put them both together like that, if we double the radius all the way across the center, we call that line the diameter. And so the three vocabulary words that we're looking at the circle right now is the center, the radius, which is the distance from the center to any point on that circle, and the diameter. And the diameter is what's called a chord, but it's a line that goes from one side of the circle to the other, and it goes through the center. And an important thing to note, and you might want to write this down, but an important thing to note is that the diameter is the same as two radiuses, radii. 2 times the radius equals the diameter. And that's an important thing to note, that if you have two radii, two radiuses, you get the diameter. So 2 times the radius equals the diameter. That's an important thing to note. All right, so that's some vocabulary. We need to talk a little bit about this number here. Letter, I guess. It's a letter. The letter is pi. It's not P-I-E like the yummy stuff you eat. It's P-I. It's the Roman number, or Roman letter, excuse me, for pi. Be like our P. It's pi. And so that's the Roman letter, or the Greek letter, excuse me. And so, but that particular symbol has some meaning in math. It's kind of the poster boy for math sometimes. We celebrate it in March. And pi is our relationship. It's a ratio. It's if we take the distance around the circle and we divide it by the distance across the circle. So if we take the distance around the circle, we measure that, and we measure the distance across the circle, the diameter. If you take the distance around divided by the distance across, you will always get the exact same number. Doesn't matter if your circle is that big or if it's this big and you measure all the way across, or if it's that big and you measure the distance all the way across. If you divide the distance around divided by the distance across, you will always get the exact same number. And we can use that fact, the fact that it's the exact same every single time, to help us figure some things out. And that ratio that we get, circumference divided by the diameter, ends up being this number here. It's about 3.14. 3.141529, blah, 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 blah. If you know through 3.14, you can do things very, very accurately on Earth. If you plan on leaving Earth, you might want to know a few more of those numbers. But really, if you're planning on staying on the Earth and making things like bridges or houses or buildings or anything with a circle, if you're going to make anything, 3.14 is plenty. That's all you really need to know. If you want to do bigger things, like if you want to build something that's bigger than the Earth, then yeah, you'll probably want more than 3.14. But for now, 3.14 is fine. We'll talk more about that and that particular number in March. 3.14 is great for calculators, because calculators like decimals. However, sometimes we have fractions. Archimedes, long time ago, Archimedes came up with this ratio that's close to pi. 22/7 is close to pi. It's not exactly pi, because pi is not a fraction. It's an irrational number. You can never write the number pi as a fraction. But we can get close to pi, hence these little squiggly lines here. We can get close to pi. It's about 3.14. It's about 22/7. And if we're using a problem, if we're using or solving a problem that involves fractions, 22/7 is what we're going to use. If we're using a problem that involves decimals or whole numbers, 3.14 is great for that. And so we've got two different options, two different numbers that we can guesstimate for pi, 3.14, 22/7. Let's see how we can use that information. So, perimeter. We said the perimeter was adding up all the sides of a shape. There are no sides to a circle. But we can still measure the distance around the circle. The perimeter of the circle is called the circumference. So the circumference is the distance around the circle. And we say then that the circumference, actually let me back up a second. I said a minute ago that pi is the relationship between the distance around the circle divided by the distance across the circle. Kept saying that over and over again. So the distance around the circle, circumference, divided by the distance across the circle, the diameter, equals pi. It's hard to measure the distance around a circle. Circles are not easy to measure accurately, the distance around the outside. And so it's often easier to measure the distance across the circle because it's a straight line. And it's easier for us to measure straight lines than circle lines. And so to measure the distance across the circle is easier. If we have this relationship, c divided by d equals pi, the circumference divided by the diameter equals pi, we can rearrange it a little bit. So if I wanted to get c all by itself, if I wanted to figure out what c equals something, if I want to get this formula for finding the circumference, I could solve for c. Well, I got c divided by d equals pi, so the opposite of divide, times. So I'm going to multiply both sides times d. These cancel off. We have c equals pi times the diameter. There we go. We have a formula for finding the circumference of a circle. So if you can measure the distance across the circle, which is easier to do, you can find the distance around the circle by taking that diameter times pi. I've been using uppercase. The official way to do it is with the lowercase. So I've got it here as pi times the lowercase d. I'm not too concerned about uppercase and lowercase at this point. But circumference is equal to pi times the diameter. So if you know the diameter, if you know the distance across, you can find the distance around the circle by multiplying times pi. So take a minute, solve these two problems, figure out the circumference of each of those circles, and then I'll put the answers up on the board, and you can either click on the link if you get it wrong, or keep moving after that. I'm assuming you paused it. I'm assuming you tried it on your own. And so the circumference, you have this formula. And so we've got the circumference of this particular circle is 25.12. The circumference of the circle on the bottom is going to be 18.84. Again, if you did not get those results, if you did not get those answers, click the link or watch the video below so you can see how to actually do this problem. Area. It's fairly easy to explain how to find the circumference of a circle, how we get that formula. Because pi, is the circumference divided by the diameter. We can solve for d or for c, And we did this already, but c equals pi times the diameter. So that makes some sense. That makes some sense. We can solve using the algebra that we already have. Area is a little bit trickier. I'm not going to go through how the formula is found right now. I'll talk in class a little bit about how other cultures have figured it out in the past, but it involves a little more calculus than we're going to worry about. So I'm just going to tell you right now that the area of a circle is pi times the radius squared. Pi times the radius times the radius. So that's the formula that we have, pi r squared, which is not true, pi r circles. But pi r squared is the formula for the area of a circle. I'm not going to get into where that comes from right now. I'll talk a little bit about it tomorrow. Otherwise, it involves some hefty calculus. So, okay, let's practice it. So use that formula, area equals pi r squared, to find the area of these two circles. So again, pause it, try it on your own. I'm assuming you paused it. I'm assuming you tried it on your own. The area for the first one here is going to be 50.24. And the area for the one below, area is going to be 113.04. 113 400ths. Again, if you did not get those answers, if you did not get those results, pause it, or not pause it, excuse me, click on the link, click on the videos below, figure out how to do this now, watch the instruction now so you don't have to try and figure it out later. Last one here that I'm going to have you do, find the area and the circumference of this particular circle. So pause it, try this last one on your own, find the area and the circumference of this circle. Okay, I'm going to assume you paused it, assume you tried it on your own. Circumference. Circumference is going to be 4.5216. There we go. And the area then, again, I'm using 3.14 for pi, 7.536. 7 and 536 thousandths. And that's the circumference, and that's the area of this circle. Okay, so try the ones below, try the assessment below, submit, and then tomorrow we'll work on a worksheet. Okay?